All right, so we're trying to first find bearings of the 85-degree angle. Now, all of these angles, or well, actually, 1 and 2, are angles in standard form. This means they start at 0 degrees and go counterclockwise until they reach the vector. They start at the 0 degree, the positive x-axis, and go until they reach their vector. This is how this is how we think of direction angles as well. Direction angles always start from 0 and go to our vector. Bearings, however, depending on what type of bearing you're finding, are different. A quadrant bearing always starts from either north or south, depending on where it's closest to. So we have never eat sour worms. Our vector is closest to which line, the north or the south? North. So putting N is close to the north. From the north, we go in which direction? Towards the east or west to reach our vector? East. So we're going to end with the east because it's going towards the east. What number should I put between these two letters? So not quite because this is the angle. This is the bearing going from the north. This little arc markation right here is the angle we're looking for. Yes, Peyton. Yes, Abby. How did you get that 5? Right. You know that one quadrant of a quadrant plane is 90 degrees in total. So if you do 90 take away 85, you'll get your bearing of 5 degrees. So from the north, we go 5 degrees east. That's our bearing. What about our two bearings? Two bearings here. Remember, two bearings always go from the north, always from the north, clockwise. So how many degrees is it from the north clockwise to reach our vector? 5, right? We literally just found it. We just found that number. It's 5 degrees from the north clockwise to our vector. Now, sometimes the bearings are written as 3 digits, but they can also just be written as 1. All right, let's look at 2. This one's just slightly more tricky. First, I'm going to find the quadrant bearing, and I'm going to label my compass north, south, east, west. I'm trying to find the quadrant bearing, meaning I have to think about which north or south my vector is closest, the closest to the north or closest to the south. So this time it's going to start with an S. And from south, I go in which direction to reach my angle, towards the west. That's my second letter. How can I find the bearing angle that goes between those letters? 3 is your, so yes. Oh, we're doing 380. You're doing 360. Yes, 360 minus 212 would give you this angle, which is fine. But then what would you have to do further? What would you have to do more to get to start people? There it is. Yes, Sydney. Instead of doing 360 minus 212, you know that three quadrants add up to 270. So if we take 270 and we subtract that purple angle 212, it will give us the pink angle, our bearing angle. So we're going to do 270 minus 212, which is 58. You got it. You could have also done something like 212 minus 180. That would subtract that purple, and it left you with this angle. And then you could have just subtracted 90 from that angle and gotten your angle, but that's a lot more effort than what we just. Okay, the bearing. This bearing is going from the north line clockwise to the four angle. How can I find this angle? Yes. Oh my gosh. Last class I was like teeth to get that. Yes, exactly. 180. So from north to south, full angle there is a straight angle. That's 180. So if we take 180 and we add the angle we just found, 58, what do we get? 230. That is our bearing. Any questions on that? Okay. So now we're going to apply it to a word problem. And I'm only going to do one word problem because I really want to use my time to do the next types of word problems. So let's look at number 4. I'm going to move this over a little. An airplane is flying at a bearing of 245 degrees at 550 miles per hour. Give the velocity of the airplane as a vector in component form. Now there's a couple of vocab words here that we need to go over. Velocity is a speed with a direction. That's what velocity is. It's the speed with direction. So if I say that I'm walking, 5 miles per hour forward, that's a velocity there. Basically, a velocity is a vector, right? That a vector is quantity with a size and direction. So if it's asking to give the velocity, what it's asking for is just give the vector. Now, also we need to know that when we're talking about speed, so here we have 555, 550 miles per hour. That speed, God, why won't it go? Okay, we'll just whatever. Whenever they give us a speed, it's just another word for the magnitude. Speed equals magnitude. It's the size, it's the distance, the length. So here, what they actually gave us was an angle and a magnitude and asked us to find the vector. We can do that. First things first, though, we need to draw the picture. Anytime you have a word problem that doesn't have a diagram, you should draw it. Now it tells me that it has a bearing of 245. What type of bearing do you think that is? It's a true bearing, meaning it goes from the north clockwise until we reach our vector. So from the north That's not three quadrants. That's not quite three. Instead, it's like two and a bit. So this is 245. Do I have the information I need to find the vector? How do you go about finding the vector? So you're really close here. You have the perfect formula. We always do the magnitude times the cosine of the direction angle, comma, the magnitude times the sine of the direction angle to get the vector in component form. And I'll write that out, but I'm going to write it's wrong in what you said here. So our magnitude is 550. First, it's cosine times the direction angle, and then it's sine. Oh God, what am I doing? Then it's magnitude times the sine of our direction angle. Why did I not put 45 there? Not the color bearing. So our when we did this last class, I believe, did our formula say the magnitude times the cosine of the bearing, comma magnitude times sine of the bearing? No, what did the formula say? What angle are we? The direction? Yes, the direction angle. Is the bearing the direction angle? No. Direction angles start at zero and go counterclockwise. That is the direction angle. How can I find that? So 360 minus 245 would give me this angle here, which is fine. I mean, that could help us. So let's see, pull this up. 360. So this would be 115. Is that our full direction angle? Yes, we can just add 90. We know that this quadrant one is 90 degrees. So to get the full angle, we could do 115 plus 90. And that is 205. Ugh, I'm running out of room to write. 115 plus 90. So that means our direction angle is 205. So now I can pull out my calculator. Guess I could just, and make sure it's in degree mode, which it is. And I do 550 cosine 205, and you get negative 498.47, comma, then we do the other one, 550. Well, I'm just going to pull this one down and change the sign to, and you get negative 232. Any questions there? All right. Are you sure there's no questions? Okay. So we're going to move on to the next type of problem. We're not going to do 7. We're not going to do 8, but we are going to do 9. Now, before we start this big long word problem, I do want to read this off. If two or more forces are acting on an object, then the resultant force is the sum of the two vector forces. What this means is, if we have multiple forces applied to an object, in order to find the total force, you could call it, you need to add the forces together. You need to add the vectors together. All right, a force is just a vector. So here, we're going to try to do this another time. Now we're going to do a couple of these. If you don't understand it first, don't worry. We're going to do a couple.